Hello, in this video, we'll be looking at the repeated string match problem and build a solution in JavaScript while also computing the time complexity and space complexity of the solution that we will be building. Before jumping into the solution aspect, let's first understand the problem statement. We will be given two input strings, string A and string B. We have to return the minimum number of times we have to repeat string A so that string B will become a substring of our string A. For example, if you have A as string A and string B is AA, let's repeat string A. So this is one occurrence. I will increment it by one more occurrence and repeat it. I will compare this repeated string with my string B. This is AA and this is A. So I can safely say that string B is a substring of string A. So I had to repeat this string, which is string A, 2 times to make sure that B becomes a substring of the original string. That's why the output will be 2. If I couldn't reach a solution, I just return -1. And having said this, let's jump into the solution aspect of it. What we need to do is repeat string A, but we have to make sure that this repetition is not going to be infinite, because we have to just make sure we find the minimum repetitions and not the maximum repetitions, because once you find the minimum repetitions, then as you keep on incrementing the repetitions, it will still say that B is a substring of A as soon as you find the first encounter of B being a substring. So we need to find the minimum number, and we can say that we repeated in this case 2 times, and then we found whatever we were looking for and then we stopped. Now let's say we will try to figure out another example wherein we have an input string as A, B, C, D, and we have another input string of B which looks something like this. So we have C, D, A, B, C, D, A, B. Now I will repeat string A. This is one repetition. This is second repetition. After I repeated it 2 times, I am still not able to get the match within the B substring, because even though the lengths are matching. So now what happened is my A had a length of 4. So this is length 4 plus length 4. Length became 8. This string B also has a length of 8. So now, although the lengths matched, I still couldn't find that B is a substring of my input string, which is A. This is because in my previous case, there was no overlap between string repetitions within our B string, because we had string A, we could go on repeating it 2 times, and then we found that it became a substring because there was no overlap between 2 occurrences. So this was first occurrence and this was second occurrence, and there was no overlap between those 2. But in this case, we can see that there will be an overlap between the third occurrence once it's introduced. So as soon as I have the third occurrence, it looks something like this, and then we can say that the string starts overlapping. So this is a repetitions chunk from the first string that we repeated. This is from the second string, and this is from the third string. So we had to take chunks from the overlap that was formed between these repetitions. So in this case, we had to repeat the strings up to the length of my string B, which was 8, and then we had to make sure that we encounter any overlaps, then that also needs to be addressed. So we incremented it just one more time, and then we again checked if it becomes a substring. So from these 2 examples, what we found that was, in the first, when there was no overlap, we could just repeat the string until the length of my string B. So the length of my string B was 2, and then we went on repeating from 1 to 2, and we could say that only we have to go until the length of my string b, and if you cross the length and there are no overlaps, then you will never find a match for that substring. But in another case, we saw that there can be a possibility of overlap wherein you have to go up to the length of b and then just try one more time to make sure that any overlaps are addressed. And that's pretty much it in terms of the approach that we take here. And now let's convert this into code and see how it looks. So first thing we said is we will be keeping track of a count that we want to use. So I will say let count is equal to 1, because you will have at least one repetition. Even one occurrence will be considered in a count. So that is, you had to repeat it at least one times to find that b became substring of a. And then in the end, we will try to find this count and return it if you make sure that b is a substring of a. And if it is not the case, then we just return -1 as a edge case. Then we said that let's keep on repeating our string a until the length of our string b, because if you cross the length, then you will not find a match. And if you have already found a match and even cross the length, in that case it's no use, because you just need the minimum number of repetitions which you need to make sure that you get your match. So I will say while the length of my repeated string, I will introduce a repeated string here which will be initialized to my a string input, and I will make sure that I will keep on repeating until I reach the length of my string b. So I will just say while the length of my repeated string is less than string b dot length, just keep on incrementing the repetition counter and also make on updating the repeated string. So I will just say repeated string is going to be repeated string dot concat a. So I will just keep on concatenating to this string of us. So step 1, we said let's at least reach the length of my b, wherein we said here you will go from 1, then you say put a check here with your repeated string. Your repeated string is length is 1, still less than the length of string b. You will go in another loop, then you will increment the counter. Now the length will become 2. Then in the second iteration you will again check with this length is become equal, so then you will exit the loop. Then after this is done, so to do this, what we noticed is that we can take at most either the length that you have for your b, so you will go up to b length, or in this case you went from 0 to up to the length of b, which was 8 plus, so you went like 4 plus 4, and then 4 plus 4 8, which was the length of your b, and then an additional repetition to make sure if there are any overlaps they are addressed. So this was the length of our string a. So you can say that considering m and n are lengths of your string a and b, to do this repetition you can take in terms of time complexity at most big O of m plus n to do this, just this step. And then what we said is, okay, you repeated it enough times now wherein the length is less than the length of your string b, wherein this was the case, then you compare. And how you can compare is simply like if the repeated string dot index of your string b is not equal to -1. So if you find the substring with this inbuilt function, it will say the index is going to be something that is not -1. If you have not found, it will return -1. So if you have found an index that is not -1, that means you have found the count of repetitions, and you just return the count that you have received, which we did in this case, wherein there was no use case of overlaps. Then we went to the next use case wherein you have to repeat the string multiple times, wherein you first reach the length of your string B and then you went an additional step of another repetition to make sure you address overlaps. So we will say the same thing again. So we will just go here and say do another concatenation, and the count we will be incrementing by one more. And now after you do the addition of one more repetition, you will do the same check again, wherein you will say, hey, is the string being a substring now after you did one more addition to make sure you address any overlaps that exist? If yes, then you will return the count, which is going to be updated now. And that's pretty much it in terms of implementation that you have. We can also say, instead of incrementing the count here, if you find, then you just say count plus 1 that you have with you. And that's pretty much it in terms of the implementation aspect that we have here. And in terms of the time complexity that it will take to take care of this operation of finding the index, that is going to be big O of n within that string that you have encountered. So we have time complexity of big O of m plus n to do the repetition aspect, and then we have this time complexity of big O of n here, and similarly time complexity of big O of n at this step also, because it is repeated, to try to find what is the step that is going to be needed. And then the overall time complexity that is going to be involved here is going to be a combination of this and this, because big O of n plus big O of n is big O of 2n, 2 being the constant, it becomes big O of n. So then it is just the product of this and this which we have, because depending on how big we have grown the repeated string, and the definition of how big the repeated string can go is big O of m plus n. And then that string having the length up to big O of m plus n, we have to try to find the index of your substring. And this check of trying to find the substring can then go within this big O of m plus n by big O of n dot m plus n. So we basically try to say that after you compute the biggest possible length that you can have, which is big O of m plus n, the operation to find a substring will take n times the length that you have with you. And that's pretty much it in terms of the time complexity. And in terms of the space complexity, we said at most you can have the length of big O of m plus n with you. That's why the space complexity will also be big O of m plus n. And that's pretty much it. Thank you for watching. Please like and subscribe.